Look at today is ionic compounds that contain transition metals. So some of the objectives for today, you should understand how to identify if a metal will form more than one cation based on its placement on the periodic table. You should be able to write the formula of an ionic compound with a transition metal, and you should also be able to name an ionic compound that has a metal that can form more than one type of cation. So when I'm talking about transition metals, I'm talking about the elements that make up the D block on the periodic table. And what you need to understand about transition metals is that they can lose different numbers of electrons depending on the situation. So all of the elements that you're looking at now that are highlighted in yellow, all of those transition metals can form more than one type of cation. So for example, iron in one situation might lose 3 electrons and take on a charge of positive 3, and in another situation it might lose 2 electrons and take on a charge of positive 2. So you don't need to have all the different charges that each element can form memorized, but what you do need to know is those elements that are transition metals that are currently highlighted can form more than one charge if they form an ion. There are 3 exceptions in the D block on the periodic table. So silver, cadmium, and zinc, those 3 elements, even though they are transition metals, they always form the same specific ion. Silver will always lose 1 electron and take on a charge of positive 1. Cadmium and zinc will always lose 2 electrons to take on a charge of positive 2. The last thing that you need to know is in group 14, tin and lead, even though they aren't transition metals, they act like transition metals because they can form more than one type of cation. So now all of the elements that are highlighted in yellow, those elements can lose different numbers of electrons depending on the situation. So as a result, they can form more than one type of positively charged cation. So check for understanding which of the following forms more than one charge. So the correct answer for that one is going to be E, both B and C. Next question, which of the following only forms one cation? That is going to be zinc with a charge of positive 2. Even though it's a transition metal, it will always lose 2 electrons and take on a charge of positive 2. All right, in the last section, we kind of talked about if you have a single monoatomic cation, how to name it. We said you write the metal's name and then you write ion after it. Now you have these transition metals that can form more than one version, more than one type of charge. So when you're naming a metal ion that has more than one possible charge, you need to specify which specific version you're looking at. So for example, we have Cu positive 1. Well, copper can form more than one type of charge. That specific version is taking on that positive 1 overall net charge. So I need to specify that it's that version, and the way that I'm going to do that is next to copper, I'm going to write a Roman numeral of 1 that's in parentheses. That is going to tell me that that specific version of copper is the one that has a charge of positive 1. So you need to start to have these different Roman numerals memorized. If you know 1 through 5, you should be good. So in order to indicate that this is the specific version of this metal ion that we're looking at, you write the charge as a Roman numeral in parentheses next to the metal's name. So now we need to look at how to figure out formulas of ionic compounds that have these transition metals that could take on more than one possible charge. So here's our example, iron 3 oxide. You could see that iron has that Roman numeral of 3 next to it. What that is telling you is that version of iron in that ionic compound is taking on a charge of positive 3. So when I go to do the formula, I'm still going to place the cation on the left. That's going to be iron with a charge of positive 3. I know it's positive 3 because of the Roman numeral. Oxide is still that anion form of oxygen that's taking on a charge of negative 2. I do the crisscrossing. I figure out that iron needs a subscript of 2 next to it in the formula unit, and oxygen needs a subscript of 3. You always still want to check to make sure if those subscripts can be reduced down. A 2 and a 3 cannot be reduced down, so that is going to be the correct formula. And based off of that formula unit, I can figure out that the ratio is going to be 2 iron ions that have a charge of positive 3 for every 3 oxides that have a charge of negative 2. All right, so you can check for understanding, write the formula for tin 4 oxide. That Roman numeral 4 tells me that tin is taking on a charge of positive 4. Oxide is going to be oxygen with a charge of negative 2. Now I can go through and do the crisscrossing. I know that tin needs to have a subscript of 2 next to it, and oxygen needs a subscript of 4. I check my subscripts. They both can be reduced down. They both can be divided by 2. So what I'm going to do is my correct formula is going to be SnO2. Based off of that formula, I can tell that the correct ratio is that for every 1 tin ion that has a charge of positive 4, I need 2 oxides that each have a charge of negative 2. All right, going from the name to the formula really isn't the difficult part. The difficult part is going from a formula to a name. Now you have these different metals that can take on more than one possible charge. So if there is a metal in the ionic compound and it can take on more than one possible charge, now you need to indicate which specific charge it is taking in that compound. So if we're looking at FeCl3, the first thing I want to ask myself is what is it made of? We have iron, we have chlorine. Remember, the metal's name needs to stay the same. But now the question I'm going to ask myself is, does it have more than one possible charge? Iron is a transition metal that has more than one possible charge. So what that tells me is I need to put a Roman numeral in parentheses next to iron's name in the name in order to indicate which specific version is in the compound. So it's going to be iron, then in parentheses, I'm going to find a Roman numeral that's going to tell me which specific charge iron is taking. Chlorine is a nonmetal. I change that ending to "ide." Now the question is, which specific version of iron is in that compound? What Roman numeral needs to be placed in the parentheses? In order to do that, I'm going to figure it out using this formula right here. What I'm going to do is take the charge of the cation and multiply it by the number of cations in that formula unit. And then I'm going to add the charge of the anion multiplied by the number of anions in that formula unit. And I'm always going to set it equal to 0. For that number of cations, number of anions part, think about it that you're looking just for the subscript in the formula unit for that part. So let's look at our example of FeCl3. So first thing I'm going to do is I'm going to analyze the cation portion of the formula unit. I don't know iron's charge in that formula unit, so I'm going to put an X. I don't know which version of iron is in that compound. Based off of that formula unit, the subscript of iron is 1, so I'm going to put a 1 for that portion right there. Now I'm going to do the second half of this equation, and I'm going to analyze the anion portion. Chloride is going to take on a charge of negative 3, and you can see based off of that formula unit that there are 3 chlorines in the formula unit, so I'm going to put a 3 down. I set that equal to 0, then I go through and simplify and solve, and I get that X is equal to 3. What that is going to tell me is when I'm writing out this name, I need to put a 3 in the parentheses in order to indicate that the specific version of iron in this compound is taking on that charge of positive 3. What I recommend is once you get the name, go through and based off of that name that you produced, figure out what formula you would get, make sure that formula matches the initial formula you were trying to name. All right, so what is the name of CRO? So I have chromium, it's a metal. I'm asking myself, does it have more than one possible charge? And the answer is yes. So I know in the name it's going to be chromium. I leave the metal's name the same. And then next to it is going to be a parentheses with the Roman numeral inside of it. Oxygen becomes oxide. So now at this point, I have chromium oxide, I have that parentheses where I'm going to have to place a Roman numeral. Now I need to go through and use that algebraic formula in order to figure out what specific charge chromium is taking in this compound. So I don't know chromium's charge at this point. There's 1 in the formula unit. Oxygen takes on a charge of -2. There's 1 of them in that formula unit, and I set it equal to 0. When I go through and solve for x, I get that x is equal to 2. So I plug a Roman numeral of 2 into the parentheses, and that is telling me that in this specific compound, chromium is taking on a charge of +2. I can check to make sure that that name makes sense. If I check my work, I have Cr +2. That's what that 2 is telling me in that name. Oxide's -2. I crisscross. I can reduce those subscripts down. So I get CrO. That matches my initial formula. Chromium 2 oxide is the correct name. Next one, what is the name of ZrO2? Zirconium is a metal. It has more than one possible charge, so I know I'm going to need to indicate what specific version of zirconium is in this ionic compound. And oxygen is going to become oxide, so I have this kind of written down so far. Now I need to figure out what Roman numeral gets placed inside of those parentheses. In order to do that, I'm using that formula. I don't know zirconium's charge. That's what I'm trying to solve for. That's the X. There's 1 zirconium in that formula unit. Oxygen takes on a charge of -2. There's 2 oxygens in the formula unit, and I set this equal to 0. When I go through and solve for x, I get that x is equal to 4, so I need to plug a Roman numeral of 4 into that parentheses right there. At this point, I need to check my work, so I'm going to check my answer. I'm saying that zirconium has a charge of +4, oxide's always -2. I crisscross, I get Zr2O4. That can be reduced down to ZrO2. The key thing is you are only placing the Roman numeral with the parentheses next to the metal if that metal can have more than one possible charge. If the metal is an alkaline metal in group 1, alkaline earth metal in group 2, or part of group 13, those metals, or silver, cadmium, and zinc, those metals only form one cation. They only form one type of charge. They don't require the Roman numeral with parentheses next to the name. It's only for these transition metals that can form more than one type of charge, and also tin and lead, since they act that way as well. In your classwork homework packet, you're going to complete numbers 29 through 32 and then 34 through 37.